In the depths of space, far beyond what we can see, something incredible happens when stars collapse, black holes collide, or neutron stars merge. These are some of the most violent events in the universe, and they create ripples in the very fabric of space and time, what we call gravitational waves. So what exactly are gravitational waves? Imagine space-time. What makes up the very fabric of our universe as a giant flexible sheet? When massive objects like black holes or neutron stars move, they can cause ripples to spread out through space-time, just like dropping a stone into a pond creates waves. These are gravitational waves. Unlike regular waves, though, gravitational waves are distortions in both space and time itself. As they pass through Earth, these ripples stretch and squeeze the space we live in. But don't worry, these effects are incredibly tiny, far too small for us to feel. Gravitational waves were predicted more than 100 years ago by none other than Albert Einstein. In his theory of general relativity, Einstein described how massive objects warp space-time, and he showed that when these objects accelerate, especially during cataclysmic events like the collision of black holes, they should produce gravitational waves. For decades, this was just a theory. These waves were so subtle that we didn't have the technology to detect them until recently. Fast forward to 2015. Scientists working with the LIGO, Laser Interferometer Gravitational Wave Observatory, made history when they detected gravitational waves for the very first time. These waves came from two black holes merging about 1.3 billion light-years away. This was a monumental discovery, confirming Einstein's prediction and giving us a new way to observe the universe. LIGO uses two massive detectors, one in Washington State and the other in Louisiana, to sense the tiny disturbances caused by passing gravitational waves. Each detector is shaped like an L, with two arms that stretch out 4 kilometers. When a gravitational wave passes, it changes the lengths of these arms by an incredibly small amount, less than the width of a proton. But how do we actually detect something so small? LIGO works by shining laser beams down each arm. Normally, the beams travel an equal distance, but when a gravitational wave passes, it distorts space-time and changes the length of one arm slightly. This difference creates an interference pattern in the light, which scientists can measure to detect the wave. It's an incredibly sensitive setup, able to measure changes smaller than 1,000th of a proton's diameter. This first detection was like opening a new window to the universe. For the first time, we could observe cosmic events that don't emit light, like black hole collisions. This has given us an entirely new way to study the most mysterious and energetic phenomena in space. Since then, LIGO and its European counterpart, Virgo, have detected dozens of gravitational wave events from merging black holes to neutron star collisions. These discoveries have confirmed our understanding of black holes, provided clues about the nature of neutron stars, and given us insight into how galaxies and star systems evolve. But this is just the beginning. Gravitational wave astronomy is still in its early days, and scientists are already building more sensitive detectors to pick up even fainter signals. The upcoming Einstein Telescope and LISA, the Laser Interferometer Space Antenna, will be able to detect waves from sources we can't yet observe, like the merging of supermassive black holes at the centers of galaxies. These tools will allow us to explore events that happened even further back in time, bringing us closer to understanding how the universe began and how it will continue to evolve. The detection of gravitational waves doesn't just add to our knowledge of the universe, it fundamentally changes the way we observe it. We're no longer limited to just studying light. We now have a new way to listen to the universe, to feel the movements of its most massive objects. It's as if the universe has given us a second sense, and with it, the potential for unimaginable discoveries. Who knows what the future holds? One thing is for sure. The universe is speaking to us in waves, and we've just started to listen. Thanks for watching. If you enjoyed this video, make sure to like and subscribe for more deep dives into the mysteries of the universe. What do you think we'll discover next with gravitational waves? Let us know in the comments below. And as always, stay curious.